Hello guys, welcome to my YouTube channel. Today we are here to solve again problem of the day, lead code problem of the day, and today is 1st October 2024, and the problem is check if array pairs are divisible by k. So let's try to read that what the problem is. You are given an array of integer and its variable name is array of even length. So it is given that it will be of even length and an integer k. We want to divide because it is even. So the question, they are trying to they are trying to divide into n by 2 pairs, n by 2 number of pairs, and each pair is divisible by the sum of each pair is divisible by k. So if you are able to make such pair, divide that array into n by 2 pairs so that each pair is divisible by k. So in this case you can return false, sorry, you can return true, otherwise you can return false. So let's see quickly that how what the example is. The example first one is you are given array and the integer k. So in this case, if you see that it should be divisible, each pair, so sum of each pair should be divisible by 5. So you can here see that. So okay, all right, and you have to make 9 and 1, 2, 8, 3, 7, 4, 6 and 5 there. Actually the problem is you have to divide each number into such pair optimally so that you can there's some of each pair should be divisible with you. So the problem is how you can divide it optimally into n by 2 number of pairs so that it could satisfy the condition. In this one also you need to have the pairs so that there some could be divisible by 7. So you can take 6 and 1, 5 and 2, and then last 3 and 4. In this way you can divide into n by 2 pairs. And in this example, if you will say that case 10, so to make it 10, what you can do, you can take it 6 and 4. Okay, all right, I have made one pair. So in the second pair you will you will take the remaining maximum values 5 and 3. It is not even be able to give the total of 10. So in this case the output is false. So this is all about the problem, and honestly I was just thinking that maybe the sorting of this array will be helpful for me at the beginning, but it was not working for me because this was already the sorted array. And okay, no, this was sorted array but it was not working. And I have also made one example. Let me show you that why it was not working for me. So I made an example like you have the element is 6 and 5 and 2 and 2. These are the array, and k value is, let's suppose, 5. So is 5. Okay, if k value is, let's suppose, is 5. So I was thinking that if I be able to sort this 5, 5, 6, could I be able to make it 6 and 5? No. So I realized the sorting will not work for me. So I rejected this approach. Then I again start to think about that how I can be able to solve the problem. So I was thinking that what the modulus actually is. So a plus b modulo k equal to should be 0 for each pair. for each pair of A and B, this condition should satisfy each time. So I thought that instead of distributing each the original element, instead of distributing the original element, what we can do is, so what we can do, so this can be used. So this will be, if I will apply the distributive property, so A modulo k plus B modulo k will be also equal to 0. So this was saying that if you are trying to make pair, you can make pair of its modulo. Instead of making the original number with the original number, what you can do, you can convert that number into its remainder. So I so so the from here a solution hit in my mind that what I can do, I can reduce the level of problem by one step if I will take the modulus of each individual element that are given in the array. So this is the way that I started to approach the problem. So okay, then I realized that okay, if I, well, let's suppose unfeasible, the if it 1 2 3 4 5 6, okay, all right, and key was 7 in the example number 2. Sorry, 7, this one is a 7, sorry, I make a mistake. Okay, this is 7. So I thought that how this is, sorry, this is already in modulo k is each element. Oh, let me make the first example. Okay, so you can see the modulus of each element will not affect the our answer. So for the each element I took the modular. So let me show you that example number 1. Okay, no, mm, these are the example 1. So what I will do, I will take modulo of each element. Modulo, this one will be 1, this will be 2, this will be 4, and then 0, and then 10 also 0, then 6 will be 1, 7 will be 2, 8 will be 3, 9 will be 4. Okay, so from here I able to visualize that yeah, I am very close to the solution. So I thought that up now the problem is reduced to something like not exactly similar to the two sum problem, but it was very similar, kind of very similar situation that you have to kind of sum that. Okay, you just have to have the two element, that if you have one, then you have to find 4, so that you can total get the 5. So 1 is given and 4 is given, so 1 and 4 I have taken, so I have removed this one and this one, and remove this one, then 2 and 2 I have removed this 2 and, sorry, 2 and then 3. Okay, 2 and 3, and again this 2 and this 3, and what I have left 1 and 4, and then 0 and 0. So exact for this case the total is not equal to 5. So this problem is not exactly equal to the to some problem, but it's kind of very similar. So but I thought, okay, this or 0 is only the cases, so I explicitly handle that. I will count at the beginning. What I will do, I will get this array, and then I will sort this array. Okay, then the array will start to look like 0 and 0. Okay, sorry, this one is 0, and then 1 and 1, 2 and 2, 3 and 3, sorry, this one 3, and 4 and 4, and that's it. So these two will be pairs, and these two will be pairs, these two will be pairs, sorry, sorry, these two will be pairs, these two will be pairs, and these two will be pairs. So if you are able to do so, then the answer is true, otherwise false. So there are the few test cases that I was I got some wrong answer because of the zero ending. Maybe you know what, that odd number, no, odd number is not, but if the count of these zero count of these zeros should be even. So let's suppose one number is given, there is a number that is giving, that is exactly divisible by 5, and then 2, and then it given the number given the modulus 3 and 2 3 5, sorry, let's suppose this one is a 4, and then something like 4 to 6. Okay, 8. So actually I'm trying to say that there might be happen that odd number of 0 can be there, so your answer could be the wrong. So at the beginning, these are from here is very symmetric, that you have to compare this one and this one, from this one to this one, and this one to this one, this one to this one, and you have to explicitly handle the case of 0. So you have to explicitly, while you didn't hit a number that is greater than 0, you have to count that you get numbers of 0 equal to even. If that are even, you can return true, and instead of this one, you have to just find that, okay, this last one, the first one, a pointer will be there here and a pointer will be here. You will just try to get the sum of these one and these one, and similarly if will hit a pair which is not giving, which is not divisible by 5, so you can return false, otherwise at the end you will have to return true. This was my approach, but this was my approach, and it's also have been accepted. And but in this, I can, this is my approach, and I when I submitted my code was accepted, so I try to see that what the hint is given actually. So I see that hint is given is exactly same what I was trying to. You might be thinking that why they are not actually doing directly modulus instead of this weird equation they have written here. So this is basically to handle the negative number, because if you are getting the remainder which is negative, what you have to do, you have to add k. So you know what, that remainder is always a whole number, that is the remainder will always be greater or equal to 0. So to handle this situation, they have written these are actually nothing but in our language is x modulo k, that's it. but to handle the negative numbers they have made this one. Actually this will give a negative number, so if you will add this that k, so it will be whole, it will be positive. So then if you will make a modulo, it will give you the correct answer. Instead of, you can also make that if these modulus are getting negatives, then you can in the modulo you will add k, and that's it. And so in one line, if you are trying to make the equation in one line, you can write it for the modulus, you can write it this way. So then I think, then actually what I'm trying to say, the the difference between my approach and yours, they said that okay, you can count the frequency of this one and this one, instead of I was just trying to get, and if you can see my approach, I was just trying to say that okay, if I ignore the zeros explicitly, then no, ignore, I if I calculate all the zeros explicitly, then from all the positive, I was just trying to say okay, 1 and 4 is given, 1 and 4 is given. So instead of making the sum, they are actually just storing the frequency. This is also the good approach, that 1 is 2 time, okay, 2 is 2 time, 3 is 2 time, and 4 is 2 time. So the total is, so whenever I will say 1, so k minus 5 minus 1 will be equal to 4. So we will have to same frequency. So 2 and 4, sorry, this one. Mm, so this and this should be have the same frequency. So 2 and 2. So alright, this one is the correct. So similar this 1 and 4 and 1 and 4 I was trying to sum. Okay, similar. So whenever when I will take 2, so remaining is 5 minus 2 is 3. Okay, then 3, then these two have the same frequency. Okay, alright, then these two frequencies are the same. So you do not need to sort the array, you can just store the frequency and just compare the frequencies and you will get the answer. But this approach I have also tried and my solution has been accepted. So at the beginning level you can also think about it and you can approach with your solution, and this will was the suggestion and the hint that was given in the problem. I also thought that yeah, this is the better approach than me. Take care of the cases when I and when I equal to 0. Yeah, I remember that. Okay, then for the 0 you also have to handle, they also have to handle 0 explicitly. So yeah, they have optimized a little bit, but they also have to handle 0 explicitly. So let's try to code and then see that how our approach will work. Let's begin with at the beginning. If everything will fine, then it will return true. Okay, but I was saying let's see, for the modulus, because the number could be the negative, so modulus, if you will simply apply this one like modulo k, this will give you the negative modulus in case of negative number. So to avoid this, what we can do is, instead of this, what we can do is, we can array of I, okay, modulus k. So these equation might give you the 0. So what we will do, we will add one extra k, then this equation will be positive, and then we again apply the modulus. This will not affect the answer. So this is the way that how we have modified the array. Okay, then let's suppose I have made the two pointer, left pointer point to 0 at the beginning, and right pointer will be and -1. Okay, and then while left is less than or equal to right. What I will say, I have said, as I have already mentioned, that we have to handle count of 0 at the beginning will be 0. So you have to explicitly, because we are trying our approach, so I will sort the array. Okay, I've sorted the array. So while array of left will be equal to 0, what I do, I will count the number of 0 and increase the left, sorry, left plus plus, and I will continue. But if this will not, the number is not 0, in this case what will I check? If array of left plus array of right modulus k is not equal to 0. So in this case you instantly you just have to return false. Okay, at the end you also have to think if count of 0 is not modulo 2 is not equal to 0, that is not in even number of pairs, so you will have to return false. These are the way that how I have coded. Let's try to, you have to also increase L plus plus, decrease R minus. That's it. Let's try to run the code. Okay, we are getting some wrong answer. Why is that? What is the problem? Mm, these are the correct, and then return false. It's always giving the false. What? Well, sorry, it's not hitting here. Why? I've also sorted the array. Let's try to print the our array. Okay, let's try to run. Sorry, I have made a mistake here. Should have this sequence. 0 0. Sorry. Okay, that was sorted. So there will be 2 0 5 and 10. Okay. Before sorting, let's see that it is working fine or not. Control X. Okay. Start to run it here. So 1 2 3 4 and 0 and 0, 1 2 3 4, this giving the correct something. The problem is here that, sorry, this have to be in bracket, I guess. That was actually the causing problem. Okay, all right, that was the problem, that it was taking the modulus of this one and then adding these number. So that was the problem. I forgot that to include the braces. So let's try to submit our code. Let me comment this debug line. So let's try to submit the code. Okay. So our code have been accepted. You can see that it beats 53.09% of the people that have has submitted in Java. Total time taken is 23 millisecond. And let's try to analyze the time complexity. As you can see that this is the linear time complexity and these are also the linear time complexity. I have the linear time complexity, but here the sorting take n log n. So our solution have the time complexity of n log n. You can also reduce to log. You can also reduce to order of n, linear time complexity, using the map, maybe has, yeah, has map, to store the frequency, so that you do not have to sort the array. So let's try to analyze the time complexity. So you can see that our time complexity is n log n, where n is the number of element in the array. So that's all about the problem. If you uh, like my explanation, you can share with your friends, and make sure you subscribe my channel and hit like, and also comment if you have any suggestion. If you have any query related to the problem, you can also ping me in the comment box, below in the comment box. Thank you. Have a very nice day and stay healthy. All right.